I'm very happy to be here and present my lab, the Centre Borelli. So I will not give you all the institutional details because it will probably take the full day. You know, the French ecosystem is very complicated, many layers, many institutions that provide funding and also staff and faculty in a research unit such as ours to develop some research programs. So I will talk about the tradition we have around AI that has been fostered for almost 30 years, even more than 30 years, and that started with work on theoretical foundations of AI. So that's why it was born in the Department of Mathematics. But along the years, we have developed this vision of how AI can be put in practice, how we can build concepts and methods that would be actionable and useful for other sciences or to build technologies. So there are a few principles, and probably that's the most important part of my talk because it's, I think, reflects a bit our vision about the topic of AI. So the first element is to consider the mathematics as a common. And my former colleague Yves Meyer, who received the Abel Prize in 2017, was talking about mathematics as a bridge between sciences and technologies. So they are everywhere. Another element is interdisciplinarity, which is a word that is used by everyone. But how can we make it work on an everyday basis? And when I'm talking about this, I like to talk about the discipline of undiscipline. In France, we like, linear careers, we like linear things. So people usually remain in their initial field, scientific field. And here we created an environment where many disciplines collaborate and there's no problem. I mean, it works quite well. It raises a few challenges, especially I think the main challenge is in terms of temporality because each domain has different times for research and producing outputs. So the mathematicians, if they publish once a year, once every 2 years, they're very happy. Our colleagues from medicine, if they don't publish every week, it's an issue. So we have this to align these different constraints. The other element is talking about fields. So talking about fields, I mean the factory, the hospital. So how can we develop research highly connected with the field? It's very different than having real experiments in a lab where everything is controlled. For instance, we work a lot in neurosciences. If you work in lab experiments, you have a high proximity to cells. If you just measure behavior in a stadium, like yesterday, on athletes, of course, we don't have the same, we cannot be as intrusive in observing the system. So, and there is a variety of situations where you can have a different type of information and data. And for us, it's very important to have this strong connection with the field, so with the expertise of the field, but with the field itself to collect interesting data that would look like real data. Another element is about what we deliver. So of course, we deliver publication, business as usual, but we believe that we should take publications one step further and really focus on making research reproducible. And for that, an online journal has been created in my lab some years ago, and it was initially thought as an internal repository for data and algorithms, but it became an open journal with a DOI, and there's a peer review process to basically evaluate not that much the novelty of what is proposed, but the fact that the algorithm is transparent, that everything is reproducible, that the dependencies are clear, that there are no hidden parameters, that everything is very explicit and can be reproduced. And there's also a demo online that allows anyone to test the algorithm on his or her own data. Another element is about the animation of this lab. And I think it's very important to be able to give some space to what we have not programmed, you know, with grant applications where we are asked to define programs and what we will do for the next 10 years. And I think it's very important to have situations where something unexpected may happen. Doesn't happen every day, of course, but I'm very happy when I see two PhD students from different fields that have been chatting for some time, and they just submit a paper, and the supervisor are more or less aware of that, because it's something that was not planned. And I think that it's very important to see a research lab as a reactive medium in the chemical sense. And then another element is, of course, thinking about the future, how we train the next generation of scientists. And for that, I think it's very important also to be in a permanent questioning about the way we train the next generations. And for us, the line to follow is to try to abolish the frontiers between training and research. So maybe it sounds like you know, political program, so not so concrete, but I can assure you that we are able to do that in Ecole Normale Supérieure Paris-Saclay, benefiting also of the size of the institution, which is quite small. So our cohorts in the maths department are less than 30 students. At the master program, we have some kind of aggregation of students coming from other universities, other engineering schools, and there we have some kind of scaling effect, but this occurs at the level of the master program. So just to give you some more elements on the research fields that we find in the Centre Borelli, and every field is connected with some structuring project. It can be an industrial chair, it can be a joint lab with another entity, it can be through this online platform I mentioned for reproducible research in image processing and information processing at large. It can be with a master program. It can be because we have also an insert team of psychiatrists working on developmental trajectories for psychiatry. And we also have a more recent acquisition, let's say, that is a platform for orientation of students in higher education. So we have, since you know there's no selection, not that much of selection in the French universities, there are many people who change their direction after 1 year, 2 years studying, and some of them are a bit lost in the system. So there is this program to try to consolidate and prepare the transitions of the students towards other fields. And there's a very interesting work on the vocational dimensions and also on the influence of the family in these choices. And we see this program as a research platform as well, because we collect many data. We have people that have a lot of expertise for 10 years now on this process of orientation. And so it's a new direction for us and a new, you know, platform from the field to work on and to develop knowledge. So there are many expertise that are available in our center. So we have fundamental researchers in mathematics and neurosciences, and many other researchers working in different fields. And we have these three major fields of application: natural hazards, industry, and healthcare. What we produce, we are about 200 people, about 30 active PIs, and about 60 PhD students, more or less, to give you some order of magnitude. And we have also medical doctors that are part of the unit. We produce about 200 publications per year, more or less 25% in math and applied math, 25% in neurosciences, 25% in computer science, and the rest is between physics, social sciences, psychology, medicine, and so on. 10 to 15 PhD theses defended per year, and about 20 software per year on average, different types of software. The online demos I mentioned before are some kind of instantiation of software production that is proposed to people that do not code. they do not know a line of Python, so they can use this software. And we also have Python libraries, the most successful being the Rupture library. Maybe people working in signal processing probably know it. It's more than 20 million downloads within 4 years now, so it's a big success. And many projects in connection with other entities and with companies, and our ongoing budget collected from these projects is about 13 million. It's not the yearly execution, it's about 3-4 million the yearly execution, but it's just to mention how intense is this interaction with other players of research. I cannot not mention our fathers, our intellectual fathers, the pioneers who started this story in the 90s, starting with Jean-Michel Guidaglia. He was a professor in partial differential equations and scientific computing, and he founded the ancestor of Centre Borelli in 1992. And this was stimulated by the stopping of the nuclear experiments in the Pacific by the French government and the needs for intense simulations. So there was this huge need for developing scientific computing. Then Jean-Michel recruited Robert Azencott from Ecole Normale Supérieure Paris, and he had a team of people working in mathematics for artificial intelligence at the time. Actually, using this word at the time was not very recommended. So things have changed. But so Robert came and he created the MVA master. It's very popular internationally, maybe not so much known in Germany, but I can assure you that it's very much recognized in the Silicon Valley. And most of the AI champions from France, they come from this master. Well, Robert also created some startups, and his original field was probability theory. He was a very theoretical mathematician. Then Yves Meyer, so Yves received very prestigious prizes, especially the Abel Prize in 2017, and he's the father of wavelet theory. So again, people working in signal theory probably know about wavelets. And then the fourth one is Jean-Michel Morel, who developed the computer vision group that is still very active today. And he was also a researcher in mathematics in PDEs. So there's a very interesting dynamic in terms of research center, contribution of institution to create the Centre Borelli in 2020. I cannot give you the full details here, but it's still moving. I think the main message here is the capacity to adapt and to permanently change the configuration of this unit, trying, of course, to stick to the initial vision. So everything is very coherent for us, but not necessarily coherent from the outside, but to have a few, let's say, lines that allow us to make the connection, and I think it's the power of mathematics to do that. For instance, all our studies on human are based on the idea of the individual and longitudinal follow-up through multimodal observations, and this allows us to develop, to contribute to very different types of applications. So I don't have too much time, but I want to mention, so I already mentioned a few of these objects that have been derived from all this stream of research. I mentioned the MVA master program, and maybe I can end my talk mentioning a few prominent alumni from this program. So probably many of you know Francis Bach. He's one of the most cited researchers in machine learning. I think in France he's probably the most cited. Olivier Clatz had a company, and he's now for 4 or 5 years the director of a 2 billion program on digital health for the French government. I cannot not mention Alexandre Biquet. He was one of my students, and I discovered his face on a bus station advertising a perfume from Yves Saint Laurent, but he also created a very successful startup in San Francisco called Crossing Minds, and you'll probably hear about Crossing Minds in the following weeks. And finally, Arthur Mensch, who is the co-founder of Mistral, who is some kind of competitor for OpenAI, developing LLM in France. Thank you very much, and I will be happy to take questions.
Thanks, Nicolas. Marcus has a question.
Yeah, thank you very much for the nice talk. I have a question about this reproducibility aspect that you've presented. So first off, how do you, it's very, very important topic, but how do you manage sort of to invest time in it where we will typically not get academic, key performance indicator out of it, like, a new paper or something like this? And then the second one that you passed the slide by, you also generate revenue with it. How?
Yeah, it's a good point. So this project, the image processing online, you can access with ipol.im online. It started with an ERC, and there was a software engineer that designed the first version of that. And then we always have some software engineer that is funded by contracts, industrial contracts, because actually this platform can be seen from different perspectives. It's very useful for academic research. First of all, because the PIs can capitalize on past work and avoid, redoing the same, rebuilding the same pieces for their research. And it boosts the citations of the regular papers, because usually this comes with a regular paper. So if you give the opportunity to make experiments, usually your paper receives more attention from the community. And the other element is that we realized afterwards that it's a fantastic vector for industrial cooperations, because it makes us very efficient in delivering, in showcasing, and it's so much efficient compared to GitHub, because GitHub is for scientists basically. But in this dialogue with people from industry or from medicine, we have to produce elements that are in a language that is out of the scientific terminology, and this makes all of the research very illustrative for the other parts. So that's how it works.
Thank you.
Thanks.
You're welcome.
Thanks a lot.